degree and leading coefficient of a polynomial. The definition for a polynomial is you cannot divide by a variable or have a square root of a variable. If you divide by a variable or have a square root of a variable, then it is not a polynomial. Degree is the highest exponent if you have a single variable, or exponent total of a term if you have multiple variables, which is the sum of the exponents. And the leading coefficient is the coefficient or number in front of the degree. Title of the first section is Find the Degree and Leading Coefficient. In this section, we'll find the degree of a polynomial and also the leading coefficient of a polynomial. First question, negative 3x squared plus 5x minus 7. Find the degree. When you have a single variable, the degree will be the highest exponent. Looking at the exponents, the highest exponent is 2, so the degree would be 2. For the leading coefficient, leading coefficient is the number in front, or coefficient for the degree. Since our degree is 2, the coefficient of that term is negative 3, so the leading coefficient would be negative 3. Next problem is 5a plus 2 plus a squared. The degree, which again is the highest exponent, would be 2. And the leading coefficient, leading coefficients, the coefficient in front of the highest exponent, which in this case would be 1. Next problem, square root of y plus y cubed. In this problem, the highest exponent would be 3, but looking at the other term, we have square root of y, or square root of a variable. And looking back at the definitions, if you have a square root of a variable, this would not be a polynomial. If you have a square root of a variable, or again if you divide by a variable, it's not a polynomial, so there's no degree and no leading coefficient. And last question for the section, 2x squared y plus square root of 2 x squared y cubed minus 4 x to the fourth. In this problem, we have a square root of a number, square root 2, which is fine, so this is still a polynomial. The degree, again, is the highest exponent, or when you have multiple terms or multiple variables, it's the sum of the exponent term. This first term would have a exponent of 1 for the y, so the total would be 3. The second term, the sum or total would be 5. And the last term, the total would be 4. So our degree, the middle term, adding the x and y exponents, the degree would be 5. And the leading coefficient, leading coefficient, again, the number in front of the term with the degree. X squared y cubed was the degree 5. The coefficient, or number in front, is square root of 2. Title of the next section is Evaluating Functions. In this section, we'll evaluate functions by plugging in numbers or variables to each function. First question, if p of x equals 3x squared minus 2x plus 5 and r of x equals x cubed plus x plus 1, find the following numbers. First part, or first question, p of 2. P of 2, or with a 2 in parentheses, means we'll take a 2, plug it into the p equation, and we'll plug a 2 in for the x values. So rewriting the p of x equation, we'll have 3, but in place of x, we can plug a 2 in, 2 squared minus 2 times 2 plus 5. Simplifying, exponents first, 2 squared would be 4, 3 times 4, negative 2 times 2 would be negative 4, and plus 5. Equals, 3 times 4 would be 12, and then minus 4 plus 5. Adding and subtracting from left to right, 12 minus 4 would be 8, 8 plus 5 would be 13. So in this question, p of 2 equals 13. Second question, r of negative 3. In this question, we'll take negative 3 and we'll plug it into the r equation for the variable x. Rewriting the r equation, we have x cubed, which in this case would be negative 3 cubed, plus x, which would be plus a negative 3, and then plus 1. Simplifying, negative 3 cubed, negative 3 times itself 3 times, and that would be negative 27, plus a negative 3 would be minus 3, and plus 1. Negative 27 minus 3 would be negative 30, plus 1 would be negative 29. And last question for the section, r of 3a. With a variable, we can plug 3a in and replace that with the other variable x. So rewriting the r equation, x cubed would be 3a cubed. And instead of plus x, we'll have plus 3a plus 1. Simplifying from here, the cubed power again will go to each coefficient and each variable in the parentheses. So 3 cubed would be 27 and a cubed. Plus 3a and plus 1 would stay the same. Since there's no more like terms to combine, this will be our final answer. 27 a cubed plus 3a plus 1. Title of the last section is Describing Functions. The definition or way we'll describe function has 3 parts. We will first describe the end behavior. End behavior will be the left side and right side of the graph and which direction it points. We'll also describe odd or even based on how the graph looks. And the last part will describe or state the number of zeros that the graph has. First graph will look like This graph is also known as a S-curve. Starts at the bottom left, curves 2 times, and points up to the top right. For this graph, again, we'll describe it in 3 ways. We'll describe the end behavior, which again is the left side and right side of the graph. We'll describe if it's odd or even, and we'll also state the number as zeros for the graph. For the end behavior of the graph, we can start at either the left or the right side. If we start at the right side of the graph goes up or up to positive infinity. So to write that, we can put f of x, which represents the graph, and we can draw an arrow after it, which represents goes to, and we'll put the sign positive infinity. So f of x, the graph, goes to positive infinity, which means the graph goes up to the right, as x also goes to positive infinity. What this means, x goes to positive infinity, means we're talking about the right side of the graph, the positive x's. The graph itself also goes up to the top, positive infinity. The second part for end behavior is the left side of the graph. The left side of the graph goes down to the left. So likewise, we can put f of x, which again is the graph, goes to, since it goes down to the bottom or negative numbers, this would be negative infinity, as x also goes to negative infinity. And again, this means the left side of the graph, since we're talking about negative numbers, the graph also goes down to the negative side or negative infinity. After end behavior, we can describe if it's odd or even. Looking at the graph, if one side points down and one side points up, this would be an odd graph. If the lines point opposite directions, that'll make it odd. If they pointed the same direction, that would make it even. And for the number of zeros, we can look at the graph. Zeros are where it crosses the x-axis at. This graph crosses once, twice, or 3 times. So this graph will have 3 zeros. So we have the end behavior, a odd graph, and 3 zeros. Last graph we'll look at for this section. Graph looks like a parabola shape, except it has 2 bottoms of the graph, or a W shape. For this graph, again, we'll describe the end behavior, odd or even, and the number is zeros. If again we start at the right side of the graph, we can put f of x, which represents the graph, goes to. The right side of the graph goes up, so f of x goes to positive infinity, goes up to the top, as x also goes to positive infinity. And again, this means as x goes to positive infinity, which is the right side, the graph goes up to positive infinity. And the second end behavior, the left-hand side, f of x goes to. The left side also goes up to the top, or positive infinity, as x goes to negative infinity. For the left side of the graph, the x values would be negative, or goes to negative infinity. The graph also goes up to positive infinity. The second part of describing functions, odd or even. Since the graph points the same direction, points up in both directions, this would be an even graph. Even again is when it points the same directions. Odd would be if it points opposite directions. And the last part's the number zeros, how many times the graph crosses the x-axis. In this case it's 1, 2, 3, 4. So this graph would have 4 zeros. So describing this function, we have the end behavior. It's an even function, and it also has 4 zeros.